Hi! We are now on to the energy unit, and we're going to be looking at a basic form of energy, and that is the capacity to do some kind of work first. So the first thing we'll look at for this week before spring break is what work is, and we're going to be taking some of these yellow notes here and doing some of the math problems so you're able to work on some of the worksheet problems. Okay, so energy, the capacity to do some kind of work, and work is the transfer of energy to a body by the application of a force that causes the body to move in the direction of the force. Okay, so it's not like regular everyday work, of course, like doing homework in class or something like that, but it's more like you have to apply a force to make an object move, and it has to move. That's really important. So like if I push really hard on the wall, I'm exerting a lot of force, but the wall doesn't move. And so I'm not doing any work because the distance in that situation is zero. So even though I'd be sweating, or like let's say doing a wall sit or something like that, the wall doesn't move. And so as a result, the overall work is zero. Work is equal to force times distance, as you can see there. And the triangle for force times distance would be something like this. Work equals force times distance. And sometimes these are paired with other problems. I think example 2 is like this today, but you might also remember that force is equal to mass times acceleration. And so sometimes you got to solve for force first, and then by using mass and acceleration, and then take that force and plug it into here to solve for work if you were also given distance. That's a pretty common sort of two-step problem for these to do. So we'll come back to both those triangles in a little bit. Work is measured in joules. In America, actually, it's measured in calories. Well, there's a few ways to measure it, but calories is pretty common for food energy. That's the amount of energy it's stored in chemical energy stored in food. Okay, so it's a little bit different than physics, making something move by force and applying it over some sort of distance. Instead, there's also chemical energy that's stored in food, and we call it calorie. And it takes our body gives our body some energy, and then we have to break it down. All right, so work is measured in joules, and we're going to look at 2 problems. You're only going through the yellow stuff today, so even though I'm scrolling down here, you will only need the yellow things today. All right, so example 1 is imagine a father playing with his daughter by lifting her repeatedly in the air. How much work does he do with each lift, assuming he lifts her 2 meters with a force of 190 newtons? Okay, so pretty straight up one there. We're going to use the triangle here. Work equals force times distance. You cover the one you want. What's left is the math you do. No, that's wrong. This is better. Work equals force times distance. Plug the numbers in. The force is 190 newtons. The distance is 2 meters. And the label for work is going to be joules. So 190 times 2 is 380, and the label would be joules. And that is the amount of work it takes to lift this kid up 2 meters. Again, here's in example 2, there's a problem where we're going to do both the triangles. Here, I'll just leave this right here so we don't have to scroll around. And it is force equals mass times acceleration. Pretty common to have problems where you do both. And here's an example where we do both. A gentleman pushes a shopping cart that has a mass of 35 kilograms, so there's your M, and it accelerates at 3 meters per second squared. How much work does a gentleman do if he pushes the cart 25 meters? So you got to do some extra work here with the mass and acceleration to find force, and then we're going to take that force and we're going to plug it back in over here to find the work, because we're also given the distance in this problem as well. Right here, the cart is moving 25 meters, so there's our distance. So to do that, first we find force. Force equals mass times acceleration. Plug that in. The mass is 35 kilograms. And the acceleration is 3 meters per second squared. So 35 times 3 is 105 for your force. So that's going to be newtons. And then we're going to continue with that and take the 105 times 25 to get our work. So work equals force times distance. We just found the force. The distance was given to us in the problem. And so we've got the force of 105 times the 25 meters for this problem. Man, I should have had a calculator with me. Hang on, chill out, be cool. We got 105 times 25, and everyone knows that answer is 2,625. 625 in the label for all these forces are joules. So you've got two kinds of problems there, sort of simple ones where you plug in and use the triangle over here. And then we've got some harder problems where you have to plug in first on this side to solve for force, and then take that force and plug it right in over here to solve for work. So two kinds of problems. We look at work being equal to force times distance, and we have work is the definition of energy is the capacity to do some kind of work. And we're going to learn some other more specific energies later, but this is the first learning about work. Okay, this has been super fun. I told you to be 10 minutes. It was 10 minutes. This has been great. Okay, everyone take care of yourselves. Bye.